Hi, everybody, and welcome to another episode of the IaC Podcast. I'm Ohad Mazish, and we're going to talk today with our amazing guest, Daniel Grzelak. Hi, Daniel.
Hi, Ohad. I'm excited to be here. Let's do it.
Let's do it. We're going to talk today about security and infrastructure as code. Tell us more about some of your background and the things you found out when it comes to IaC in your career.
Yeah, look, so I'm currently Chief Innovation Officer at Plarion. Plarion's a cloud security company. And what I do there is a lot of my work is doing technical security research and then talking about it. So that's how I started with this Terraform thing is recently I did a little bit of Terraform security research and found some really interesting attacks on Terraform.
Attacks. Okay, so let's talk about some attacks. What makes you worried as a with a security background when you see infrastructure as code?
Yeah, look, so I might take you back to like what was the impetus for this whole idea. So I used to work on a red team for an organization. A red team, for anyone that doesn't know, is an offensive security team that tries to emulate attackers. So the idea is we pretend to be some group of attackers. We use their tools and tactics to try and test if an organization can be breached, and then what do they do if they're breached. So on one of these engagements as a red team, we were able to gain access to the organization's AWS account, but it was like a limited access. It wasn't the whole, it wasn't admin credentials. It was a simple role that could access a few S3 buckets. And so we were trying to figure
And
out.
did you find anything interesting in those three buckets?
We did. Good question. Um, so basically, yeah, we found these S3 buckets. We looked around in them, and one of them happened to have something called like a file called terraform.state. And we were wondering what could we
A
possibly
plain
do?
text, a plain text file.
Plain text terraform.state file, exactly. And we were trying to figure out what can we do with this? Is there anything possible? Because it's such a limited scope. Like, yes, you can read some data in there's three buckets, but if it's not confidential data, then what do you do with it? And at the time, we kind of like we thought there was maybe something to it, but we left it. And so fast forward a few years, now I get to do cloud security research as my job. Um, I remembered this engagement, and so I started to think about, hey, like maybe I should come back to this topic. What could we do if we landed in a limited context, or an attacker landed in a limited context inside a AWS account or a Google account or whatever? Okay, so I started poking around and playing with state files and what could you do. The first thing I found was that, actually, I might just step back and say, what is a Terraform state file? For those that don't know the internals of it, it's just a reference of the infrastructure that was deployed. It's a JSON file that says, here's all the resources that Terraform has deployed. Okay, so what can you do with that? Well, the first thing you can do with that is if you change one of the references, like an ID of a resource to some other resource, the next time Terraform tries to build infrastructure, it'll say, "Hey, that resource with that ID, it's not in my Terraform file." Okay, clearly that someone's changed the Terraform file, so we should delete that resource that doesn't exist. And of course, if you set that ID to a resource that does exist in the account, Terraform will go ahead and try and delete it.
Right.
So
Yep.
that was the first attack.
Yep.
Uh,
But for that, you
but
need write access to S3, not just read access to the S3 bucket.
exactly. So the attacks basically assumed that you could write or change the state file inside the S3 bucket.
Yep.
So that was the first one. But there's a far more interesting attack and far more dangerous attack. What I found was that if you inserted a reference to a provider, so a provider is basically any kind of like a cloud infrastructure provider, or think AWS, Azure, but also
Yep.
think like DNS providers and whatever else. So anyone basically can create their own provider, a custom
Yep.
provider. Okay, So if you could insert a reference to a custom provider, what actually happens is when Terraform runs the plan function is for Terraform is it just tells you what are the changes that are going to be applied when we actually do the deployment. And it allows people to review the changes and see if they make sense, make sure that there was no errors and they're not mucking this up in any way. But
Yeah,
it turns out
what's called a dry run. Mhm.
a dry run, exactly. But it turns out when you do that, as part of that plan function, it loads all of the providers that are specified in the state file. And if you specified a custom provider that you wrote, it will go ahead and load that provider and run all of its initialization functions. So for those that are following along, it means that an attacker or a good guy like me who's just doing research or a bad guy who's an actual attacker can create their own custom provider, publish it to the Terraform registry, and in the initialization function, put some malicious code, say something that calls back to their infrastructure or downloads all the secrets and sends them back to some other place. And when the pipeline runs Terraform plan, it will actually go ahead and run that code. And effectively, you can take over that CI CD pipeline by running your own malicious code.
Yeah, you can execute whatever you want with this custom provider.
Exactly. Exactly. And the implication of that is that most CI CD pipelines have full access to accounts because you
Yeah.
want to be able to deploy and change infrastructure at will. And so if an attacker can run code in that pipeline, they effectively have full access to your, say, your AWS infrastructure, for example.
Yeah, yeah, yeah. I think it's pretty scary, to think about what can be done with some access to a state file. And you as a security red team person, now, unlike a few years ago without infrastructure as code, now with infrastructure as code, you might look first for those plain text state files, because if you get a hold of those, you can do a lot more damage by some of the techniques you've mentioned. And it's important to also remember two very important facts. One, as you just mentioned, that most systems that use something like Terraform they have full write access to the cloud account, let's say AWS, and trust and hope that anybody that executes that code uh, is only intended executions and not unintended executions. And the second thing that is important to mention, that this is the de facto standard today of how you store state files. So if you have Terraform, you just execute Terraform locally with what's called a local backend. It makes no sense, because then the next execution by somebody else, it will not have access to the local state file. So you need to store it somewhere that is reusable by the next executions. And AWS S3 buckets is maybe the most common way for you as a user to store those state files. So now, in addition to some application data that you might store in your S3 buckets, you also have this super important plain text infrastructure related file that has a lot of potential damage. From my conversations with Terraform users, their biggest security concern is about properly storing the state file and how to properly give the right access to team members to those, let's say, S3 buckets. And it's something that you need to manage and to take care of, as long as you use infrastructure as code, right? So is that what you feel the same?
Um, I, I'm actually so that is a concern for me. I'm actually more worried about the pipelines themselves. So, for
Yep.
example, if you use GitHub Actions to deploy your Terraform,
Yep.
what you're in most organizations, what you're actually doing is taking the permissions that were put into AWS and you're shifting them over to your
It.
CI/CD pipeline,
Yeah.
yeah, to
Yeah.
Git,
Yeah.
and because now the Terraform has access to your AWS account through the pipeline, the people who are able to change code have access to your pipeline. And then, so what I've found, I've been a CISO at various organizations and led security teams. I found what actually happens is because you're separating those two and you're moving that security from one place to another, the security team has less involvement in the pipeline space. And it's the
Yep.
developers and engineers who are setting up the security for the pipelines. And they don't necessarily understand like the nuance of what's just happened by shifting the security from one place to another. And so you get in a situation where, the whole engineering org or even the entire organization has the ability to um, edit that code, to do pull requests and review and accept pull requests on that code. So you're essentially saying through this chain of trust relationships, everyone in your organization has admin access to your AWS account or your Azure account, which is not a good situation to be in because obviously, like, that's so many people who can have their workstation compromised, right? Through no fault of their own. That's so many people that, you know, if you let them go, they can, become disgruntled and potentially make a malicious change. There's lots of things that can go wrong. And the other interesting thing I've seen is it's not just the people and their workstations now that you have to worry about, because GitHub has a very rich plugin ecosystem, and so do other CI/CD providers. And so,
Yep.
in some cases, now what you're actually saying is all the plugins that are able to read and write pull requests now have admin
Can affect
access.
my production. Yeah. Can affect
Yeah,
my
it's
production.
and so the explosion of all the things that can go wrong is mind blowing.
Definitely. Wow. So I want to share some personal story here. And usually I don't talk much about NF0 in this podcast, and I try to keep it isolated between my day job and this podcast, which is a part-time hobby of mine. But because you've mentioned that, I want to say and I want to share how NF0 started. So for me, I remember I was working with a big insurance company in the United States, and I needed them to change something in an ELB, in a load balancer, and I was expecting that person to click a button in the GUI of AWS and to change some configuration. And then I've noticed some things for the first time. Uh, so it was a long time ago. I remember that person say, "Okay, I'm going to change that configuration," opening GitLab, writing some Terraform code, and then merging that code. Only then I've realized two things: A, that his AWS access was read only, and I've never talked, with an engineer that needs to fix cloud resources that has read-only access. And on the other hand, the credentials that GitLab had were unlimited. And I'm thinking, wait, AWS invested so much effort in advanced role-based access system, and now it becomes irrelevant because humans get read-only and CI platforms get full access. So what's going on? What is the role-based access when it comes to cloud with code? And that later on evolved to N0, in which, for example, you can define that some code can never be run in production, that there are some approval workflows, some of those may be manual approvals for some cloud accounts, some configuration, variables values that cannot be allowed to run some policies that are enforced, such as Chekhov and others, open policy agent, to make sure that bad code will not be executed by the wrong people in the wrong cloud account, and go and so on and so on. So yeah, what you mentioned is every code change without the proper guardrails, if you put it in something generic such as GitHub Actions or Circle CI or Jenkins, those platforms don't have the logic and the awareness of what it means an infrastructure change. They just execute commands. So if somebody has access to change code that triggers a command, or if somebody has access to a plugin in your GitHub that then changes something, the risk factor is now much bigger. And I really like what you said about it's also a different team. Those that care about pipelines, they think about automation, they think about self-service, they think about productivity. They are not in they don't talk all days with red teams and how to attack uh, your environments. For that, it's like the security team, sometimes the DevSecOps teams that are working alongside the DevOps teams that care more about the automation and the deployment lifecycle. So that's indeed super relevant, and we see that in NF0 every day. Customers approach us saying that they lack a persistent way to govern public cloud deployments that are done through infrastructure as code, and they need to minimize the risk without damaging the collaboration and speed. Well, what are your thoughts about what I've said?
Yeah, I think that's right, and I think the incentives for the people working on the CI/CD pipelines are so different to the incentives of the security team, right? Even if you have that discussion and you explain the issues with this to the team, and they say yes, we agree, let's go fix it. There's two things that'll happen. One is like it might not be prioritized as high because obviously you're trying to get that productivity, etc. But you also have to not break the development workflow. And sometimes when you're fixing these issues, you're going to have to like either redesign it end to end or you're going to have to break things along the way to be able to move quickly, and that's a hard trade-off for people to make. And so you end up typically teams end up putting in these like band-aid solutions. Okay, well, instead of having 1,000 engineers be able to do pull requests, we'll make it 800. But like that doesn't materially reduce the risk, and you really need something like your product that you were talking about, or a completely like redefined paradigm to
Yep.
actually build it from the beginning.
Yep. And maybe before we finish this discussion today, I want to go back to, plain text state files, and I cannot ignore the fact that in the next version of OpenTofu 1.7, there's going to be a, a new capability, which is the state encryption, meaning the state file, let's say stored in S3, will not be plain text, it will be encrypted, and the key will be stored in a total different place. How do you think that will affect the risk factor for working with IaC and working with Terraform?
I mean, I love the feature. I've been looking at it with the team. So first thing is if we go back to the scenario we started with, where you, as an attacker, you land in an AWS environment and you see this S3 bucket with the Terraform state file. The first thing you'll notice then is you won't be able to read it. So if anyone's accidentally left any secrets, or if it's obviously explains all the infrastructure that was deployed with Terraform, the attacker won't be able to understand and see that. They won't be able to capture the secret and use it. So that's amazing. And obviously, if they can't read the state file, it's going to be extremely hard to edit it. And obviously, if they try and edit it, the encryption works in such a way that it'll um, turn the whole file into mush. And so it can, yes, if implemented correctly, then this entire attack scenario basically goes away. And so I think it's a big step forward in terms of security.
Yeah, yeah, and we're very proud to introduce that. It was one of the biggest asks by the community, and OpenTofu 1.6 was just compatible with Terraform 1.6, but OpenTofu 1.7 is both compatible and introduces a couple of innovations. One of which is the state encryption. We've been hearing a lot of great feedback about this long-awaited capability and how it's going to dramatically reduce the the risks for organizations working with OpenTofu, unlike Terraform. Awesome. This has been a great conversation, Daniel. Thanks for coming today and talking more about security, because we don't just need to think about how we automate and scale. We needed to always understand that this is part of um, a big picture, and security is always a main concern, a main topic to be involved when you think about your solution. So thanks for shedding some light on some important topics. Anything you wanna say to our audience today?
It's been amazing. Thank you. And if anyone wants to read the full technical details, the whole write up is available end to end on blog.plarion.com.
Sure, and we'll be happy to link that in the episode description as well. Great. Thank you so much, Daniel, and thank you everybody for joining today. Up until the next time, this is the IaC podcast. Have a great day.